Hello, and welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 853, car fleet. So for this problem, we're given n cars going the same destination along a one-lane road, and the destination is target miles away. So you're given two arrays. One is the position of the cars, and one is the speed of the cars. So the two arrays are of the same length, and the at position at I, say this is, so I would be, if we're looking at the first car, the position would be 10 and the speed would be 2. So the positions and the speed both line up with the I. So the position of the second car would be 8 and the speed of the second car would be 4. So given these arrays, we have to figure out, well, if there is one car and this car is traveling at 20 miles an hour, and there's another car, and that car is behind it, and it's driving at 40 miles an hour. This car, the car that's behind it, because it's going at 40 miles an hour, it's going to eventually catch up to the car in front of it, which is at 20 miles an hour. And then those cars, it's going to drive at the same speed now because it's only a one-lane road. So it can't pass the car ahead of it. So it's going to go, instead from driving at 40 miles an hour, it's going to be up here. It's going to be right behind the car that's driving 20 miles an hour, and it's going to have to go 20 miles an hour as well. And so the car can never pass another car ahead of it, but it can catch up and drive bumper to bumper at the same speed, and the faster car will slow down to match the slower car's speed. And we can note that when these two cars are driving together, we are the distance between those two cars is ignored. So we are basically saying that they are driving in the same position. And when the two cars are together like that, bumper to bumper, this is called a car fleet. When the cars are driving together. And so our task for this problem is to find the number of car fleets at the end when they reach the destination. So how can we solve this problem? Well, one thing that we can do is we can draw our cars on a number line. And so given our arrays for our position and our speed, we can draw a number line where car 1 is at position 10, car 2 is at position 8, car 3 is at position 0, car 4 car 4 is at position 5, and car 5 is at position 3. So they all are starting at a certain starting position, and then they are going a certain speed. So the speed at that they go is a certain number, and that's going to tell you how fast it's going to take them to get to the target. So the car at position 10, how long is it going to take it to get to the target? Well, it's going to take it the distance that it needs to travel, which is our target minus our current position, and then it's going to be divided by the speed that the car is going at, which is 2. So it's going to take 1 hour. If these are miles an hour, it would take 1 amount of time for it to get to the 12. And so if you now if you look at the car behind it, how long is it going to take that car to get to the position 12? Well, it's going to take 12 minus 8 and divided by the speed, which is 4. And so that's going to be 4 divided by 4. It's also going to take 1. So these cars are actually going to get to the target in the same time. Okay, so you know that those cars are actually going to become a fleet because they're going to get to the target at the same time. Now, what about the car in position at position 5? So it's going to take 12 minus 5 divided by how many? So it's at going 1, so it's going to be 7. So it's going to take 7 hours. So this one's going to take 7 hours. And what about the car behind it? It's going to take 12 minus 3, and then this 3 is going a speed of 3, so it's going to be divided by 3, so that's 9 divided by 3, which is 3. So it's going to go 3. So it's going to arrive there at 3. But is it really going to arrive there at 3? Because it's going faster than the car ahead of it. So the car ahead of it is going to arrive in 7 hours, and it's going to arrive in 3 hours. So that means that eventually this car is going to it's going to catch up with the car in position 5. So these cars are going to be a fleet. And then we have our last car, and that car is going to do 12 minus 0 and divide it by the speed it's going at, which is 1. So it's going to take 12 hours, and it is not going to catch up with any other cars because it's going too slow. So that's essentially how we can determine how many fleets are in there. So there's 3 fleets. So I forgot to say that if one car is by itself, it's a fleet of 1 car. So there's 3 fleets, and that's the answer. Our answer is 3. And you can see that that is the output. So that's how to determine how many fleets. But how are we going to do this programmatically? Well, what we could do is use a stack. We could use a stack, and what we could do is loop over the positions and speeds backwards, because remember we were going backwards, because we always want to see if the car behind a car is going to be catching up with the car in front of it. So we want to loop backwards. So we're going to loop backwards, and we're going to determine our time. So we're going to determine our time it takes for one car to get to the end point. So this car was taking 12 minus 10 divided by R2, which is 1. So this was taking 1. And there's nothing on the stack right now. So we're going to put a 1 on the stack. Now we're going to check our car behind it. And now, is this car going to catch up? Well, this car is going to take 12 minus 8 divided by 4. So this is going to be 4 divided by 4, which is 1. So this car is actually going to catch up. So if the car that we're on looking at, its time is greater than the top of the stack, we're going to, that means it's going to be a fleet. And so we're going to add that to the top of the stack. But, that means it's going to be separate. It's not going to be a fleet. So because this is a fleet, we don't want to add this to the top. Because this is 1 is not greater than 1, it's not greater than 1, then we're not going to add this to the top of the stack. So now we look and we calculate the time that it's going to take this car. So the time is 7. So we look at the top of the stack, and is 7 greater than 1? Yes, 7 is greater than 1, so we're going to put that on the top of the stack, because that's going to be a new car, it's not going to be a fleet with the other car, it's going to be a new fleet. And so now we're going to look at the next car behind it. So that is 3. That the time it's going to take to get to the end is 3. And so is 3 greater than 7? No, 3 is not greater than 7, so that means it's going to catch up. So that means it's going to be a fleet. So the stack is keeping track of how many fleets. And so for everything we're adding on the stack, that is a new fleet. So since 3 is less than 7, it's going to catch up. That means it's not going to be a new fleet. It's going to be a part of this fleet. So we don't add anything to the stack. And finally, the 12. The 12 is 12 less than the top of the stack, which is 7. 12 is greater than the top of the stack, which is 7. Yes, 12 is greater than the top of the stack, which is 7. So we're going to place our 12 on the stack. And now at the end of the algorithm, we are done, and we have 3 things on the stack. So the length of our stack is 3, so we return 3, and that is the answer. So that's the algorithm for solving this problem. This runs in O of n time, because we're going to loop through in reverse, but it's O of n time plus O of n log n, because we actually had to see how we plotted it on a number line and we did it in reverse, so that means we sorted it. So because of the sort, it's going to be n log n, and so O of n plus n log n is just going to be O of n log n time, and because of that sort. And then because we're using a stack and we place at most place n things on the stack, it's going to be O of n space. So that's the algorithm, and let us see it coded up. So the first thing that we're going to need to do is we're going to need to combine our position and speed arrays into one array, where it's going to be an array. We're going to have an array of position and speed tuples, because we're going to need to sort by our position, and we're going to need to have the position and the speed, so we're going to need to put it in one array together. So what we're going to do is use a list comprehension for that, which is a Python feature. So we're going to do positions and speeds is going to be an array, and we're going to have each thing in the array is going to have a tuple. It's going to not a tuple, it's just going to have an array of position and speed, because we need to sort it and tuples can't be sorted. So we're going to need an array of position and speed, so we can just call that P and S. And for P and S in, and we're going to use the function called zip, which will loop through these two position and speed arrays at the same time, position and speed. And so this is going to take the first position in the position array and put it in this new array and the first position, and it's going to take the first thing in the speed and put it in this new array for the speed. And so it's going to give us all of our positions and speeds. So then we're going to have our positions and speeds, and then we're also going to have a stack, which is going to be an empty list. We can use a list in Python for a stack, because we're just going to be pushing and popping. So now we're going to, for position and speed in our positions and speeds, but we're going to need to sort this by position. So if we just do this sorted, then this will sort this by position. And we also need to go in reverse. So this is how you go in reverse in Python. This is the syntax for :-1 will give you a array in reverse. So it's going to be reverse sorted by the position. And so now we're looping through our positions and speeds. Now we need to get the time that it takes to target, and the time that it takes to target from our formula back at when we were going over the algorithm was going to be our target minus our position that we're currently at, divided by our, not integer division, we're going to use decimal division in case we get a decimal number, and divided by our speed. So that's going to be the time. So now we're going to be appending to our stack. So now we want to see if our time, so if our stack is empty, then we want to append to the stack. So if our stack is empty or our time to target is greater than what is on our stack. So it's if not stack. If there's nothing on the stack, then we're going to append to the stack. And if that's the case, or the time to the target is greater than what is on the top of the stack, which is stack -1, then we're going to append to the stack. We're going to append our time to target onto the stack. And that's it. At the end, we just need to return the length of our stack. And that is the algorithm. It's pretty, that's the code. It's pretty short. So let's run it. And it was successful, so let's submit. And it was accepted. And so that is how you solve that problem. Thanks for watching, and I'll see you in the next video.